Also, apologies to those who are hearing me for the third time today. You have my sympathy. There's just so much good stuff to talk about. I couldn't just pick one thing. So today, I'm going to talk about a subject that's kind of important because the NoSQL big data space is very crowded. It's a very crowded space. There's a lot of options out there, and all of them are complicated. So being able to choose the right tool for the job and be able to intelligently explain why you chose that tool instead of emotionally, like you have some attachment to it, is really, really difficult. And I think for the most part, people probably many times don't really get a deep understanding of each of the options that they have, because it's almost impossible. A lot of the things that you discover about a particular tool, you don't discover until you're several months down the road and perhaps maybe $1 million into your implementation, which is difficult. So I wanted to do kind of as deep a dive as I could on Accumulo, HBase, and Cassandra. In no particular order. If you're familiar with this movie, I'm not calling anything bad or ugly. It just came out that way. Trying to go to the next. It's not working. Oh, it's because. There we go. Hey. Okay. Lost focus because. Oh man, you see the little box. So, okay, we're gonna talk about Accumulo, HBase, and Cassandra. And for each one, I'm going to talk about the architecture, the data model, security query support, gotchas, and popularity. And I think these are reasons why you should consider using something. So, the basic architecture and data model makes sense. Does it fit your problem? Security. I mentioned that because Accumulo is kind of reason for being. Part of it's the reason for being a security. So if you can't justify Accumulo for security reasons, that's interesting. Query support is interesting because it differs so much across projects. Gotchas are things that I try to bring out that are things that you might not discover for a long time until it's too late. And then finally, popularity, because support and things like the community around a particular project are quite important. So, and we're going to cover a lot of ground pretty quickly, so we're just going to dive right in here. Yeah, it just keeps doing it. I think I have to keep this on here. Okay, so Accumulo, very quickly. It's a computer software product developed a sorted distributed key-value store based on big table technology from Google. It's been known publicly to store on the order of 100 trillion things in a single table, entries. A single instance can be on thousands of servers, sometimes over multiple instances of HDFS, so it's extremely scalable. We're just going to put that stake in the sand early. The architecture Accumulo is built on the popular Hadoop kind of big table architecture. So it runs on top of HDFS. You don't need MapReduce, but it's there. And then it runs on Zookeeper as well. One thing about Accumulo is new tablet servers join the cluster immediately because the responsibility for serving data is decoupled from the storage of the data. So HDFS does the storage and replication, and Accumulo tablet servers can serve data from different places in HDFS if necessary. They tend to do it locally, but you can do it from other places as well. And that means that new machines can join the cluster very quickly and start serving queries. Fans of the CAP theorem will recognize this is a consistent partition-tolerant system, which means it gives up availability in the presence of partition tolerance. So what that means is if a machine dies, the portion of tablets that were on that machine will be unavailable until the responsibility for serving those tablets can be picked up by the remaining tablet servers. So usually that's on the order of seconds, but it is a type of unavailability. So other systems have effectively zero unavailability, but they have to sacrifice consistency, which means sometimes you'll always get an answer, but sometimes your answer won't be the most new version of the answer. Whereas with Accumulo, every time you get an answer, it's guaranteed to be the definitive latest answer. And the way that works is Accumulo allows each key to be managed by one server. So Accumulo has key value pairs. If you ask for what the value of a particular key is, you're guaranteed to get the latest one, and that's because exactly one server manages that at any given time. Other systems let two servers handle the writes for a single key, which means that one of them is always going to be behind a little bit. And if you get your answer from that one, you're getting a stale answer. So Accumulo doesn't have that problem. But on the other hand, if that server goes down, you're going to have a small amount of unavailability. Whereas other systems, one of those two servers can go down and the other one can answer instantly. So you have no unavailability. So it's just a difference between two basic choices people make in the NoSQL space. Accumulo has a metadata table that can split and grow. It just makes it extremely scalable. That's based on Google's big table design. The data model looks like this. So I said it has key value pairs, but the key is complicated. The key is made up of three primary components: row ID, column timestamp, and the columns further split into three things. It's mostly like big table, except for we added the column visibility. And that's so you can restrict certain values from being seen if you don't have all the authorizations to see a particular value. So the column visibility is a first-class component in the data model. It's actually right in the key, and it's not even the last thing in the key. It's the next to last thing in the key. So it's an integral part of the system. Security filtering is implemented in a way that you can't turn it off. The column visibilities are human readable. They're not mapped, so there's no chance for confusion. Accumulo has a true implementation of something called locality groups. So locality groups let you treat Accumulo as a columnar database. Some databases are row-oriented, where you have to read all the fields in one row before you read the first field of the next row. Columnar databases let you read one column from each row before you read the next column of the first row. Accumulo lets you balance between those two. So it's row-oriented for the most part, but you can take certain sets of column families and group them together on disk. So for example, if you have a bunch of web data you crawled, you can store the content separately than the metadata, and so when you only want to scan the metadata, you don't have to read all the content off of disk. So it has this nice true columnar capability, which is fantastic. This is how it looks when you store it on disk. So you can't see anything there. So this may be so these are supposed to be shaded. It's too light to see. So this is kind of what I described. You can have web page content and web page details, metadata in one row. These are all describing Apache Accumulo's Wikipedia page. But then you can store the details up here and the content down here. And so you can scan across different rows for certain sets of columns, like just the detail columns, and read all that without reading off all the content, which is a big deal because the content could be like several orders of magnitude bigger than the details. So these columnar scans will be fast, whereas if you didn't group it this way, you'd have to skip over all the content every time. So it's an optimization. Security is a big part of Accumulo. We built it in from the beginning. It's on by default. You have user group roles and style access control. But then you have this cell level security via these column visibilities that I mentioned. It's fail-safe, which means if you kind of mess up, you don't see data. A common problem is people will start writing data to their table, and they'll be like, I did a scan, and there's no table there, or there's no data. And it's like, well, okay, but there might be data. You just don't have access to read it. And that's because you haven't set up your security credentials properly. So Accumulo won't fail open and like spill its guts out. If you don't give it exactly what it needs, it's just going to pretend there's no data, which is great when you work in a system that you don't want to have mistakes result in leaks. And then the security label operators are very simple. You have and and or, and that's it. There's no not, which will come up later. Query support, no secondary indexing capabilities built in. There's several secondary indexing patterns that are well supported. Long rows, a batch scanner, iterators let you do this embedded indexing thing that I was talking about earlier. If you look up doc partitioned indexing and things like that, you can see there's no official query language, though. So there's just a low-level API. You don't have anything like SQL or even a minimal subset of SQL. There's nothing like that. So which means you have to write clients using Java. There's some gotchas. Usually, honestly, this is probably true of all NoSQL databases. You got to tune it. You can't just use it what what Cloudera gives you out of the box. Somebody's laughing. Yeah, it's ridiculous to use what Cloudera or Hortonworks give you out of the box. You got to tune it. Some people will I guess I've run into people. It's not really anyone's fault, but it's like some people have 2 tablet servers and like hundreds of clients, or maybe thousands of clients, I guess. And it's like, well, you only have 2 tablet servers. You might want to beef that up a little bit, I guess. You should be able to serve hundreds of thousands of users per client is why. So if we're talking about millions of users and like 2 tablet servers, I don't know, you might want to have more tablet servers. Many small tables versus few large tables. Accumulo can have issues if you have like many tables. Big thing is the community is just not as big. So there are a lot of people using Accumulo. It's the 60th most popular database in the world, which out of all the databases that's pretty good, I would say. But the community could be bigger. There could be a lot more free online resources like tutorials and blogs and stuff. And then there's this trend going on where servers are getting bigger, which means that individual server failure results in more data needing to be replicated. So imagine you lose a server with 24 terabytes on it, and now you have to replicate that. Accumulo at least doesn't force you to replicate that data before you can have a fully functioning cluster, but that impact of that re-replication can be non-trivial. Like I said, 60th most popular database overall. It's the 4th most popular wide column store behind Cassandra, HBase, and now Microsoft's Azure Cosmos DB. Does anyone know what that is? Yeah, it's about a 16th as popular as HBase, so it's a distant 4th, or 3rd if you don't count Cosmos. But it's more popular than a lot of things like Apache Drill, Oracle's NoSQL, LevelDB, VoltDB, I don't know, Cloud Bigtable, that's cool. It's more popular than that. Now, this is just like this kind of superficial web database engine popularity ranking, but it's interesting to me. And it's still growing. So it was growing really rapidly, even as recently as 2013. It kind of had this peak. There were actually several peaks, maybe around January 2016. I don't know what was going on in January 2016, but job postings peaked for like big data overall, and almost all the databases peaked right around January 26th. But so it settled down, but then now it's growing again. And I would say of the 4 wide column stores that I mentioned, Accumulo I think is growing the fastest. These are some recent improvements in 1.7. Point is, progress is being made. I just got to skip over this. I have a bunch of slides. And in 1.8, there's some interesting things happening. Some of these address some of those trends I was talking about. Now you can run multiple tablet servers on one node. So if you have really beefy nodes, you can actually address the fact that the Accumulo is designed for smaller nodes by running multiple tablet servers per one node. So that's cool. This is a cool effect of speeding up the write-ahead log rollovers. Above this is what just happened before. When you're doing a write-ahead log rollover, your streaming ingest would kind of take a nosedive for a little while, and now it's better, and it's even slightly higher than on average. So there's progress being made, which is fantastic. Okay, on to HBase. I got to try and split this up. So HBase is when you need read-write access to big data. It wants to host very large tables, billions of rows times millions of columns on commodity hardware. So billions, you say? It's like billions is nice, but we like trillions better. So actually, if you do the math, a billion times a million is a trillion. But again, Accumulo has been shown to do hundreds of trillions of things, or on the order of 100 trillion things. So I don't know. I'm just saying. Nobody's out there claiming that HBase can do 100 trillion things, but not to say it couldn't. Architecture is the same as Accumulo's, except for some little differences in the way it stores this metadata table, which may or may not impact its scalability. Ultimately, it doesn't split its metadata table, as far as I know. Does anyone know better? Does anyone know that it actually does split the metadata table? Okay. We're still clear on that. Okay, so Facebook and others didn't like the recovery time associated with a single server going down. Remember I mentioned if a single server goes down, Accumulo recovers fairly fast, but they still didn't really like that, how fast it was. So they introduced something called read replication, which completely goes to the other side of the CAP theorem and says now we're going to let data be read from multiple tablet servers. But the same key can be read from multiple tablet servers. So that kind of introduced the ability to have higher availability at the cost of consistency. And so Hortonworks says that goes from 99.3 nines to 4 nines. Facebook claims a similar design, which apparently doesn't look like it's going to be added to HBase. But it looks like there's ways to push it to 5 nines. Anybody have off the top of their head how many minutes a year these nines are? 4 nines is like an hour. 5 nines is like 5 minutes. That's cool. I'm the only one who knew that off the top of my head. I had to look it up too. I don't know. Anyway, so I talked about read replicas. That's a thing in HBase. I think it's interesting that they're doing that. So like if that's something you need, HBase might be your thing. It requires more memory, but not more storage. I thought that was interesting. Sorry, I'm moving so quickly. Data model's the same, except for a big glaring feature, in my opinion, which is HBase doesn't implement locality groups basically at all. Each different column family is like a locality group. So you can't have multiple column families per locality group, and you can't really have that many locality groups. I was reading about this, and you have to declare them up front. I was reading about this back in 2009. Someone was like, you probably want to have less than 100 column families. And then Google's big table says, unlike in HBase, you can use up to 100 column families while maintaining excellent performance, implying that HBase doesn't perform well around 100 column families, which I thought was interesting. And then the online guide said, it doesn't really do well with anything above 2 or 3 column families. So, you want to keep it low. And then about a paragraph lower than that, it says, really just use 1 column family. So basically, you don't have column families. You get 1. This was just interesting. I don't know what the limits actually are for Accumulo. I think they're higher, though. So it's just saying 10 to 50 megabyte object in HBase, like a value, the size of a value, would be a lot to ask. Now, there's a special thing called MOB that lets you use things up to 10 or 50 megabytes, but that's like a special feature. So I think Accumulo goes beyond that, but just pointing out HBase says that's about the limit. Security, typical group role-based access control. They did add cell-level access control in 2014, and it relies on something called a coprocessor, which is kind of like the analogy to Accumulo's iterators, except it's outside the memory space of the tablet server. To use it, you got to turn on version 3 H file storage. So it's not turned on by default, first thing. You got to turn on version 3 H file storage. The visibility controller has to be added to the list of coprocessors, and you have to use a Hadoop group mapping mechanism. There's no built-in way to manage groups in HBase. And if you use replication, you got to be careful. Do something special to make sure the visibility labels aren't lost. So I bring this up because these are all things that could potentially cause like data leaks if you don't get them all right. There's another thing called the not operator, which effectively means that if a client fails to report all of its credentials, you could result in an elevation of privilege. You could start seeing things that maybe you weren't supposed to see. So in my opinion, that makes clients more dangerous to write. Query support. Despite several attempts, there's no, it looks like people have just relegated themselves to using Solr with HBase for secondary indexing. Like, you could maybe do something similar to what we do in Accumulo, but they just don't. People just don't. I mentioned a lot of gotchas. Those are some gotchas. It is the second most popular wide columnar store, about half as popular as Cassandra. Still growing in popularity, but growth has slowed. I would say just eyeballing it, not as fast as Accumulo, but it's a lot more popular already. Actually, and if you look at job postings for HBase, I think that's the only one where they might be declining a little bit. I don't want to start any rumors. I'm just saying. Okay, Cassandra, finally. This is, okay, it's obviously marketing speak. When you need scalability and high availability without compromising performance, blah, blah, blah. So what they did with Cassandra is interesting. They took aspects of Amazon Dynamo and mashed it into Google's big table. So it is designed to run across data centers, which means it's a AP system. They sacrifice consistency for availability, but you can kind of tune that. So if you're running it in a single data center, you can say that a write has to be confirmed in a quorum before it's considered successful, so that gives you high consistency. The one nice thing about the architecture is very simple. All the nodes are the same. There's no masters, there's no zookeeper, and the storage is coupled with the service. So in order for a Cassandra node to serve data, it has to have a local copy of it. Now, they can talk to each other, but that has implications with regard to recovery. Inside a Cassandra node, it looks very much like a tablet server. So it has a mem table, SS table, which is like the same thing that Accumulo uses. It's got compaction, sorting, etc. It uses a gossip peer-to-peer protocol, though, to bring things up. So it's kind of interesting. It uses a really cool idea called consistent hashing to decide which keys live on which server. So important design in Cassandra is the keys aren't just dynamically assigned to nodes. They're deterministically assigned based on this consistent hashing mechanism. So you can't just move things around willy-nilly like Accumulo does. Accumulo will migrate tablets just as it sees fit. You can't do that with Cassandra. The other big difference is they've completely covered up the original data model and API with this CQL abstraction. So you build tables like a relational database, and you use CQL to query it. But you can still uncover roughly how it's using the data model if you read carefully. You have these thing called partition keys, and that decides which server a row belongs on, and then so it can be one or more columns from your table, and then clustering columns determine how the rest of the data is grouped within the partition. So that's pretty confusing. So I'm going to give you an example. Here you got user IDs, the partition key, and then these two things are the clustering columns, and these other things are, I guess, what you call regular columns. I think this is how it works. You hash the partition keys to find the prefix of your row ID, what would be your row ID in Accumulo. And then the other clustering columns become the other parts of the row ID. So those are sorted, and so they're going to be grouped together. That's how they get the word, clustering column. And then within that, you have your other columns and your values. So obviously, you can query on user ID. That makes sense. You can, within a user ID, query on some clustering columns, and you can do some range scans as long as it is like a trailing wildcard on your clustering column set. So like you can't fix the video ID and then scan across timestamps if you organize your table this way. You have to pick a timestamp, then you can scan across video IDs or a portion of these or whatever. So that has an impact on the types of CQL queries you can do. But that's pretty opaque, compared to this. This is basically how you model your data, and you just have to know that this is what's going on. The dynamism appears to be gone from the data model. Like you have to tell Cassandra up front all the columns you're going to have, and you have to tell it what type they are. So it's much more like a relational database, and I believe that contributes to its popularity. The columns are even typed, so you can't even store different types. The security model is similar to relational databases, nothing really special here. It does have row-level access, but it relies on exact string matches, which is less flexible than Accumulo and HBase. Column-level permissions are not yet implemented. Again, you got this thing called CQL. You use it to define table schemas and querying, and it has built-in secondary indexing. I want to talk about what the limits are, though, to that. So this is an example, if you were in the other talk, of embedded indexing. So the keys the original records are distributed by the partition key around the cluster. And then for each key, all the indexes related to this record are stored with it. So that's my definition of an embedded index. This is embedded with the original data. So what's nice about that is if you want to query on something other than your partition key or your clustering columns, you can. But you have to do that kind of go to every node and ask it what it knows kind of thing. But this is where that round-robin technique comes in. You don't have to query all the machines at once, but you start interrogating nodes, and then they just send you back what they have. Go back real quick. So as you might guess, if you're used to using Accumulo, having a hash of the user ID be the first thing you query on means you can't do range scans on user IDs because the hash destroys any locality you had in the user ID by design. And then only these lookups on partition keys or clustering columns are efficient without secondary indexing. This is all about gotchas, right? So there's a bunch of gotchas. So if you're reading about Cassandra, you're like, holy crap, it's got secondary indexing built in. It's got this high-level query language. This is amazing. This is much more like relational databases. I really want to use this. I think that does, like I say, contribute to its popularity, but you got to know kind of how that may or may not bite you in the end. So if you don't want to query for a particular user, like in our previous example, it won't do your query at all. It's like, you have to at least tell me what user you're talking about. I won't let you do any scan over a column like Accumulo will, unless you turn on this thing called filtering, which is turned off by default because it's effectively a table scan. It's possible to order your partition keys to allow range scans, so you don't have to hash your partition keys. But again, that's not the default. Without all the clustering columns in a query, it will be rejected unless filtering is on. So it sounds like it won't even let you query on like across a range of clustering columns for some reason. Except for if you do range scans like I described, where you're only doing it at the end of the clustering columns. The secondary index fields only support equality. So it's possible in Accumulo, in fact, very common to build secondary indexes that allow range queries. That's usually the case. That's not possible in Cassandra. And then obviously, querying on something that's not indexed is not allowed unless you allow table scans. And then I told you that it has this cool round robin thing that I think Accumulo could adopt, to make it less expensive. All right, here's some more fun caveats. Avoid very low cardinality index. This one kind of makes sense. Like, don't index the word the, don't index the gender field, because you're only going to have a few unique values for that. So like, one value is going to point to half your database or a third of your database. And then avoid a very high cardinality index. Now this one is really painful. So normally, in like a traditional relational database, high cardinality fields are great. So by cardinality, I mean things with a lot of unique values. So like user ID is if you know, that's something that querying on it is a great query in a relational database because it gets you exactly one row and then you pull it back. The problem is for secondary indexes, Cassandra has no idea where that one row is, so it's going to query the first node, and it'll be like, do you have it? And it'll be, nope. And it'll query 2 more nodes. Do you have it? Nope. 4 nodes. Do you have it? Oh, maybe like the third or the fourth has it. So high cardinality fields are not recommended, which is a very common use case, in my opinion, and it's something that's easy to build with Accumulo indexes. And then we talked about how, or you may know that if you have to update values frequently, having an index on that makes that expensive because you have to update the index entries as well. Okay, other gotchas. Adding a replacement node can take a long time, literally days to like over a week if you have like a bunch of data to replicate. And that's because you have to replicate, Cassandra doesn't let a server serve data from anywhere else, so you have to have all the data replicated before a node can start processing requests. Other people recommend not using hinted handoffs. Large number of tables like in Accumulo can be problematic. And then I thought this was interesting. Netflix said they had 9,000 nodes, but then they had hundreds of clusters, so which means they probably don't ever run clusters much larger than 100 nodes. I always find that interesting. Like, you know, it's got to be administratively easier to run one big cluster than it is many, many small clusters, I have to assume. Maybe the security doesn't allow that. So popularity, it totally wins the wide columnar store contest. It's the 8th most popular database overall. It's like more popular than Teradata, at least online. I don't know if that means by installs or whatever, but the popularity has plateaued. So I would say this one's growing the least of these 3, but it's way up there. So which one to use? I did some informal sampling. So Cassandra and HBase have this cool like powered by page, and if you go look on there and you categorize all the companies that are using it, this is kind of what you find. HBase is very popular with backing web apps. It's popular at social media sites like Facebook. It's used for marketing. And then this category is interesting. There are about 4 or 5 or 6, I guess, companies out there you can find that are building solutions on HBase that they're selling, like tools. There's, I thought that was interesting. Nothing like that for Cassandra. Cassandra has somewhat of a similar profile, not quite the same. It's used much more in enterprise. My hypothesis is some people are using Cassandra as a relational database replacement, and it's less of a laughable proposition when you realize that CQL allows you to use Cassandra somewhat similarly to how you were using relational databases. So I think that's what's going on there. Cassandra is used in gaming companies, interestingly, and in cloud. And I think part of it is a lot of the developers were from Rackspace, but Amazon is also using it. If you just look at relative usage by job postings, Accumulo is like overwhelmingly defense contractors are hiring Accumulo folks. Now, we do see finance companies hiring Accumulo people. This morning I mentioned Accumulo is being used in lots of places, telecom, healthcare. It's being used in marketing, and HBase has maybe a good, strong finance component, a smaller enterprise, bigger in telecom. Cassandra looks like, and they also have defense components, though, here. This is interesting. Not a lot of defense for Cassandra, but some for HBase. Retail is kind of a big one for Cassandra, and cloud. So two kind of ways of looking at this. Ideas for maybe Accumulo I think Accumulo's biggest problem is just its adoption, and part of the adoption is I think Accumulo has a good stronghold in places where it's really the best fit, but I think it could be even more popular if we can make it maybe easier to use. Community support is a great thing. Maybe more free resources would be great. And then this is a really intriguing idea of having some sort of a way of making it easier to build indexes so you're not always reinventing the wheel. So now you're armed with everything you need to win your next NoSQL shootout with your manager, your coworkers, or whoever. Any questions? Everybody's good. Anybody see anything inconsistent or incorrect? You guys are like, I can't deal with this. Too much detail. Cool. Thanks, everyone.